Okay. So here we have an implicit equation. Make sure I finish that first. Okay, coming back. And I went ahead and sketched the curve. I went ahead and graphed it for you. So that's the graph of that equation. Of course, it's not a function, doesn't pass the vertical line test. But obviously we can see that it should have different rates of change, right? So I mean, you see different slopes along that curve. So we want to find dy dx. So let's find a formula for the derivative of that. So we're going to take d dx of both sides. So d dx of the left equals d dx of the right. I guess I should do that technically. All right, so on the left side, the derivative of x with respect to x, that's simply going to be 1. Okay. Plus, the derivative with respect to x of y, that's going to be dy dx. You okay with that? All right. On the right side, when we take the derivative with respect to x of this expression, we have to use the chain rule because, well, we don't have to, but I think it's just easier to do it that way, right? So you could always multiply this out, but we're not going to do that. So we use a chain rule initially. Apply the chain rule here. When we do that, that's going to be 2, keep the argument the same, and then multiply that by the derivative of the inside now, right? Which we have to apply the implicit there. You get 2x plus, yes, 2y. So when we differentiate the y squared, we have to use the chain rule there. So the 2 comes down, 2y, and then take the derivative of y with respect to x. So that would be dy dx. Like that. So let me see here. And I'll just tell you, where did that come from? That was d dx of x squared plus y squared, right? Just in case, just for notes. All right, now, cleaning up, we need to solve for dy dx. So I'm going to leave this one here alone, d1 plus dy dx for a moment. I'm going to deal with this side here. I mean, let's just go ahead and we're going to distribute this whole expression here. This 2x squared plus y squared, we're going to multiply that times 2x. That's going to give us 4x times x squared plus y squared plus 4y dy dx times x squared plus y squared. Are we okay with that? See what I did there? So I just multiplied this whole thing here times both of these. And that gave me that. Now I'm going to drag all the stuff with dy dx. I'm going to drag this whole term here. It doesn't really matter which way you go with it. I'm going to take that whole piece. I'm going to subtract it over to the other side with this other dy dx. And I'm going to subtract this 1 over here. So I want to get all the terms with the dy dx to one side. Okay? So doing that, we get that dy dx minus 4y dy dx x squared plus y squared is going to be equal to 4x x squared plus y squared minus 1. Now, you notice that we have a common factor of dy dx, right? So I'm going to go ahead and factor that out of those two terms. So if I factor out dy dx from those two terms, we get dy dx times 1 minus 4y times x squared plus y squared is equal to 4x times x squared plus y squared minus 1. And then you know what I'm going to do next, right? I need to get dy dx by itself, so I'm just going to divide both sides by the 1 minus 4y times x squared plus y squared. So I'm dividing over this whole term here. Okay, so that's going over to the other side. So my final result, dy dx, is going to be 4x, and I think I'll just leave it like that. And I'm going to take a second look at something, see if we can clean it up even more. But this is what we'll have here. All right, any thoughts about that? One. So ddx of cosine xy equals ddx of 1 plus sine y. When we differentiate, chain rule, because cosine's the outer function, xy the inside function. So the derivative of cosine is negative sine. We keep its argument the same. We then multiply that by the derivative of xy. There we need to use the product rule. So the derivative, you can do x times the derivative of y. So you can write it as x dy dx plus the derivative of x, which is 1 times y. So you have that. All right, so just in case for later, this was ddx of xy, right? The chain rule. All right, and then on the right side, the derivative of 1 is 0. The derivative of sine y, use a chain rule there. So the derivative of sine is cosine. We keep its argument the same. And I might even just put a parenthesis around this. So, and then I multiply that times the derivative of the inside. That's going to be dy dx. So I just put parentheses there just so it's clear that the dy dx is not in the argument of the function. It's on the outside of the function. Okay, now I need to solve for dy dx. So on the left side, I'm going to multiply that through. So that's going to be negative x sine xy dy dx minus y sine xy equals cosine y dy dx. I'm going to go ahead. It doesn't really matter which way you go with this. How many did you bring the x sine xy with the cosine y, or did you bring the cosine y over to the other side? Which direction would you move the dy dx? Left or right? Move it to the... Okay, I heard more rights. It doesn't matter, but yeah. So I get negative y sine xy equals cosine y dy dx plus x sine xy dy dx. Then I'm going to factor out the dy dx. And later on, this just could be a mental thing. Just do it in your head. And then now divide both sides by cosine y plus x sine y, sine xy. So your final answer is that dy dx is going to be equal to negative y sine xy over cosine y plus x sine xy.